Okay, this is question 18. You are asked to find the sum of this expression. So the sum of the log is actually equal to log of the product. What I mean here is the sum of log is equals to the log of product. So we need to use this property. That's number one. Number two is when k equals to 16, this term is equal to 0 because it is sine 2 pi. And this is square root of 1. So you have log 2, 1. Log 1 is equal to 0. So you just basically plus 0. So we can just end at k equals to 15. They will get the same value. Now we let ak to represent the expression here. So call this is j, and therefore j is equal to summation k1 15 log 2 ak. And according to the property here, this is equal to log 2 a1 a2 a3 all the way to 15. So we are going to combine log 2 a1 and a15, a2 and a14, a3, a13, and so on and so forth until a7, a9, and a8. Then I continue here and note that a16 minus k is actually equal to square root sine square 16 minus k pi plus 1 minus sine 16 minus k pi over 8. Now, this is actually equal to sine 2 pi minus k pi over 8. So simulate from here. But this is actually equal to plus sine of k pi over 8. So this is negative of 8, but after you square it, it is actually the same. So it is sine square k pi over 8 plus 1. And the next thing that we observe here is the product of ak, a16 minus k, is actually equals to one is plus and the other one is minus. So the product of this will be x minus y, x plus y. And it will mean that x squared minus y squared, so it will be equal to sine square k pi over 8 plus 1 minus sine square k pi over 8. So this is equals 1. Now, this applies to all the k from 1 to up to 7. So each of these is equal to 1. Each of these is equal to 1. So we have 1 to the power of 7. What happens when k equals to 8? When k equals to 8, this is equal to sine 8 pi over 8. That's sine pi. Sine pi is 0. So this is square root of 0 plus 1. Again, this is 1. So the product here is equal to 1. So log 2, 1 is equal to 0. And therefore, 0 is the answer for question 18.